All right, on this homework, there's a bunch of different types of problems. I'm going to go through as many as I can. This first one, we've got two square roots, and there's no way to get either square root by itself efficiently. And so we're just going to go ahead and square it and use properties of quadratics to simplify. We're going to square this side, and we're going to square this side. And when we square this side, 2 square root of x times 2 square root of x is going to be 4 times square root of x squared. We have square root of x squared, that'll just be x. Here, we get negative 3 square root of x. These are two things. We're using the property of exponents that ab squared is a squared b squared. A times b times a times b is a squared b squared. So this is 9 times this squared is x minus 2. Notice I have to put parentheses to make sure the 9 multiplies times both. So 4x equals 9x minus 18. We're going to get x by itself here. This is just solving a linear equation. I'm moving 4x to this side, 18 to this side by adding 18 and subtracting 4x. And so x is 18 fifths. I do need to check my answer. So we're going to get 2 square root of 18 fifths equals negative 3 square root of, I need to do 18 fifths minus 2, and I'll do that over to the side here. 18 fifths minus 2. I need to change this into a fraction. This is 18 fifths minus 2 over 1. And to get a common fraction denominator, I'm going to get multiplied by 5 over 5 here. So this is going to be negative 10 fifths. And so 18 fifths minus 2 is 8 fifths. And this is kind of weird. It's hard to compare whether these are equal to each other, but it's quite clear that they're not. And the reason is this is a positive number, and this is a positive number times a negative number, which is a negative number, and those cannot be equal to each other. So even without a calculator to see are those two decimals the same, it's clear that they are not. And so our answer does not work. It's an extraneous solution, and there are no solutions to this problem. The next one, we want to get x by itself, so x plus 2, we added the 1 to the other side to isolate the square root. We're going to square both sides. Here we have a binomial squared. You can multiply it out as x plus 2 times another x plus 2, but we should know a square binomial trick by now, I hope, where we square the first one. We multiply these two together, which is 2x, and double it, 4x. And then we square the last one. This is a quadratic equation with multiple x's, so we're going to get the equation equal to 0 by subtracting 6x and subtracting 10. So I'm subtracting 6x, subtracting 10. And then I'd like to factor this, but after looking at it for a second, I see it can't be factored. And so I'm going to do the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. This is, I'm going to go up here, 2 plus or minus the square root of 28 all over 2. And I need to simplify the square root of 28. This is square root of 4 times square root of 7 is square root of 28, and that's 2 square root of 7. So 2 plus or minus 2 square root of 7 divided by 2. This is a binomial being divided by 2. I can distribute. They both get divided by 2. 1 plus or minus the square root of 7. Notice I put the 1 here, but not here. The reason is this one would be multiplying, and you don't need to write a one that's multiplying, but we do need this one that's adding. All right. I think this is the last solving equations one I'm going to do. Here there's no way to get the square root isolated, and so I'm just going to square it and deal with the ugliness that ensues. This side's easy. Squaring the square root is 3x minus 2. But this side is a binomial because it's separated by this plus. So we're going to square the first one, multiply these two together, and double it. So negative 1 times the square root of x plus 3 doubled is negative 2 times the square root of x plus 3. And we're going to square the last one. That cancels out the square root. Now I have only a single square root, and so I'm going to isolate it by subtracting 1, subtracting 3, subtracting x, and so 2x minus 6 equals negative 2 square root of x plus 3. I'm going to divide by negative 2, although I could just square it right now if I really wanted to. It would make it harder. So I'm going to divide by negative 2. This is a binomial. It distributes. So negative x plus 3 equals square root of x plus 3. I'm going to square both sides now that I have my square root isolated. I'm kind of hurrying through this because there are a lot of problems I'd like to get to before the memory on my phone runs out. When we multiply these two together and double it, we get negative 6x. Here, this cancels out. The square root and the square root cancel out. And this is a quadratic, so I'm going to, again, make it equal to 0. When I do that, I get x squared minus 7x plus 6 equals 0. X minus 6 times x minus 1 equals 0. So x is 6 or 1. Now that I've got x is 6 or 1, I need to check it. When I plug in x equals 6, I get 3 times 6 is 18, minus 2 is 16, square root of 16 is 4, equals 6 plus 3 is 9, square root of 9 is 3, negative 1 plus 3 is 2, and that does not work, so 6 is an extraneous solution. When I plug in 1, it does work, and so x is 1 is my solution. That's the only solution. On the back, got some inequalities. And we're going to solve them similar to how we solve a square root equation, except we're going to have to do a little bit more checking. 2x minus 1 is greater than or equal to 1. So 2x greater than or equal to 2. X is greater than or equal to 1. Okay, this looks like our solution, but we need to check two things. One, when we plug in 1, does it make this, if it were an equation, does it make it true? If not, we'll have to check more things. When we plug in 1, 2 minus 1 is 1, square root of 1 is 1, so it works. That's the first check. The second check is the domain of this ever violated? We can't have square root of a negative, therefore 2x minus 1 always has to be greater than or equal to 0. That way it won't ever be a negative value. And so when I solve this, I get 2x is greater than or equal to 2x is greater than or equal to 1, so x is greater than or equal to 1/2. So this is saying, for my solutions, the x's always need to be above 1/2. And as long as x is above 1, they will also already be above 1/2. And so that, this is true. They'll both be true when x is greater than or equal to 1. Compare this to this next one. Same steps. So when we solve, I'm going to do 2 steps at once here. We get x is less than 1. But when we check our domain restriction, the domain of this square root has to be above 0. So again, we get x is greater than or equal to 1/2. But this time, not all numbers that are less than 1 are above 1/2. For instance, 0 is less than 1, but 0 is not above 1/2. What that means is when we plug in some of the solutions here, we'll end up with square root of a negative, and the inequality will not be true. So I need to do a compound inequality where the x is bigger than 1/2 but less than 1. And the way we write that is 1/2 less than or equal to x less than 1. X is in between 1/2 and 1. These are the x's that are above 1/2 but below 1. Okay. One more type. We're going to solve it just like normal. When we divide by negative 1, remember we have to switch the sign, because when you divide by a negative, we switch the sign. That's what we just did. When we square both sides, we get 4. And we need to check our 2 things. The first is, when I plug in 4, does this actually work? And it does, kind of. When I plug in 4, square root of 4 is 2. Negative 2 plus 3 is 1. 1 is less than or equal to 5, but it's not equal. And so there's something weird going on. And what's going on is when they're not equal to each other, either it will always be true or never be true. And in this case, it will always be true because 1 is less than or equal to 5. This was a true statement, but they're not equal. And so as long as the domain restriction is true, so the thing inside the square root has to be above 0, as long as x is above 0, this equation will always be true, not just when x is 4. The answer is just x is greater than or equal to 0. Because these weren't equal, and it was a true statement, this will always be true as long as you can do the square root. For instance, square root of 1. If x is 1, square root of 1 is 1, negative 1 plus 3 is 2, and 2 is still less than or equal to 5. So that's what's going on there. I will do one more total problem. Let's do a quadratic inequality. Here we're going to factor it. And what we're going to look for is where is this equal to 0 first? When x is negative 7 and x is 2, this equals 0. But we're looking for where it's above 0. We're going to make what's called a sign chart. And we're going to see at different x's, what are the values here? We always skip a space, then put our lowest 0. We skip a space and put our highest 0. And the way this looks is we're going to say at different x's, what is the sign? When I pick a number less than negative 7, I can pick any number less than negative 7, like for instance negative 10. When I plug it in, I'm going to use the factored form. Negative 10 plus 7 is negative 3, which is a negative. Negative 10 minus 2 is negative 12, which is a negative. And a negative times a negative is a positive. When I pick a number in between this, like 0, for instance, any number in between, we're going to get a positive times a negative, which is a negative. And when we pick a number bigger than 2, like 5, we'll get a positive times a positive, which is a positive. We're looking for where is this above 0, and it'll happen as long as x is less than negative 7 or x is above 5. Or above 2, I apologize. Another way we could write this is the interval from negative infinity to negative 7 union the interval from 2 to infinity. All right, that's all the time.